One of the greatest scientific dreams began more than a century ago, the dream of uniting the fundamental forces of nature. This journey aimed to bring gravity and electromagnetism together into a single elegant framework capable of describing the universe in its entirety. This idea was more than just mathematics. It represented a vision, a belief that beneath the complexity of the physical world lies a deep, unified order, a single theory that could reveal the true harmony of nature's laws. Although the early attempts did not fully succeed, they paved the way for many of today's most ambitious scientific theories. In this episode, we'll take a closer look at this groundbreaking concept and its lasting impact on modern physics. If you're passionate about scientific discovery, stay with us and let's uncover the story behind one of the boldest ideas in the history of science.
Welcome to For Science Salah Lotfy channel, where science meets curiosity. في هذه القناة لا نكتفي بعرض الأبحاث العلمية، بل نترجمها إلى المعرفة التي تصل إليك أينما كنت. Our mission is to make global scientific research understandable, accessible, and multilingual. جميع الفيديوهات العلمية هنا مترجمة إلى اللغة العربية، بالإضافة إلى لغات عالمية أخرى. French, Spanish, German, Urdu, and more. Because science speaks every language. نعم، العلم يتحدث بكل اللغات، ونحن نحرص أن يصلك بلغتك. If you're passionate about science, you're in the right place. اشترك الآن وابدأ رحلتك مع العلم خطوة بخطوة. For Science Salah Lotfy channel, العلم للجميع.
Welcome to For Science Salah Lotfy channel. Today we will revisit a story that began 100 years ago. A story of one of the most ambitious scientific quests in modern history. It is the quest to unite the forces of nature under one grand, elegant theory. And to guide us through this remarkable chapter, we will explore the insights shared by Dr. Yosri Haddad, a distinguished Tunisian physicist based in Europe. Dr. Haddad earned his PhD in physics, worked as a researcher at the French Atomic Energy Commission, CEA, Commissariat à l'énergie atomique et aux énergies alternatives, and is the founder and president of the Network of Arab Science. Through his official page, he continues to share knowledge, history, and scientific thought with the Arab world and beyond. In 1925, Albert Einstein submitted a short but significant scientific paper to the Prussian Academy of Sciences in Berlin. The title of that paper was Unified Field Theory of Gravitation and Electricity. This was not just another research paper. It was part of Einstein's great dream, the dream of finding a single, unified framework that could describe both gravity and electromagnetism as two different manifestations of one fundamental field. Einstein had already revolutionized physics with his theory of general relativity in 1915. But he wasn't satisfied with describing gravity alone. He wanted something greater, a theory of everything. Einstein envisioned a universe governed by a set of deep, elegant, and deterministic laws. At the heart of his idea was the structure of space-time itself. He believed that if one could properly modify the mathematical geometry of space-time, using tools like the metric tensor and the affine connection, then gravity and electromagnetism could be expressed as parts of one unified field. This was more than mathematics. It was a philosophical stance. Einstein was convinced that the universe was fundamentally ordered, and that beneath the surface of apparent randomness, there existed a precise and complete mathematical description of reality. But as Einstein pursued his vision, the field of physics was undergoing a revolution of its own: quantum mechanics. Physicists like Niels Bohr, Werner Heisenberg, and Max Born proposed a probabilistic interpretation of nature, known as the Copenhagen interpretation. They suggested that at the microscopic level, events do not follow strict, deterministic laws. Instead, they follow probabilities. Einstein could not accept this. He famously said, "God does not play dice." To him, quantum mechanics was not wrong, but incomplete. He believed it was only an approximation of a deeper, deterministic theory still waiting to be discovered. This philosophical divide between Einstein and the emerging quantum community became one of the most defining debates in 20th century physics. The 1925 paper represents one of Einstein's first formal attempts to construct a unified field theory. He tried to modify the geometry of space-time so that both the gravitational field and the electromagnetic field would arise naturally from a single mathematical structure. Although elegant, the approach faced major challenges. It could not explain the behavior of matter at quantum scales. It lacked experimental verification, and it struggled to compete with the success of the newly born quantum mechanics. Einstein continued to work on this problem for decades, even after much of the scientific community shifted its focus to quantum mechanics and nuclear physics. He never gave up on his dream of unity. Although his unified field theory remained incomplete, it laid the foundation for later ideas, from modern string theory to quantum gravity research. The original handwritten manuscript of that paper is preserved at the Hebrew University of Jerusalem, a testament to one of the greatest intellectual journeys in modern science. As Dr. Yosri Haddad emphasized in his post, this moment was not just a scientific milestone, it was a statement of Einstein's unwavering belief in the deep harmony of nature's laws. 100 years later, scientists are still searching for the theory of everything, a framework that unites gravity with the quantum world. From Einstein's handwritten notes in 1925 to the frontiers of modern physics, this dream continues to inspire generations of physicists. A special thanks to Dr. Yosri Haddad, Tunisian physicist, researcher, and founder of the Network of Arab Science, for bringing this historic moment to light through his official page. His work reflects the spirit of scientific curiosity and intellectual engagement that transcends borders. If you'd like to read more about this theory and Einstein's vision, you'll find the link to Dr. Haddad's original post in the comments below. Don't forget to subscribe to For Science Salah Lotfy channel for more inspiring stories from the world of science. Einstein's dream of unity is not just a story from the past. It is a roadmap for the future. Welcome to For Science Salah Lotfy channel. In today's episode, we will explore one of the most fascinating and ambitious chapters in the history of modern physics. A story written in the elegant handwriting of Albert Einstein himself. This is not just any paper. This is the original 1925 manuscript of Einstein's Einheitliche Feldtheorie von Gravitation und Elektrizität, or in English, Unified Field Theory of Gravitation and Electricity. This document, now preserved at the Hebrew University of Jerusalem, represents Einstein's relentless pursuit of a single, unified description of the forces of nature. Let's go back to the year 1925. The world of physics was in the midst of a revolution. Albert Einstein had already transformed our understanding of gravity with the publication of his general theory of relativity in 1915. Meanwhile, a new and radical framework, quantum mechanics, was emerging through the work of Niels Bohr, Werner Heisenberg, Max Born, and others. But Einstein had a vision of his own. He believed that nature, at its most fundamental level, must be governed by a single, elegant set of laws. He wanted to unify gravity and electromagnetism into one theory, a theory of everything. When we look at the first page of the manuscript, we see Einstein's handwriting at the top. Einheitliche Feldtheorie von Gravitation und Elektrizität, A. Einstein. This title alone reveals the boldness of his ambition. Below it, in carefully written German, Einstein introduces the motivation for his work. He speaks of the need to bring together the gravitational field and the electromagnetic field into one consistent mathematical framework. This was a direct continuation of the line of thought that began with his field equations of general relativity. In the following paragraphs, Einstein explains the mathematical structure of his idea. He uses the language of differential geometry, focusing on two central concepts: the metric tensor, which describes the curvature of spacetime, and the affine connection, which governs how vectors change as they move through curved space. Einstein's strategy was to modify these mathematical objects in such a way that both gravitational and electromagnetic phenomena would emerge from them naturally. We can see the first set of equations written clearly, starting with the field equations that attempt to generalize his earlier work. While Einstein was pursuing this grand vision, most physicists were focusing on quantum mechanics, which had introduced probability into the heart of physics. But Einstein was deeply uncomfortable with the probabilistic interpretation of reality. He famously said, "God does not play dice." To Einstein, the universe was not a game of chance. He believed that quantum mechanics, while successful, was incomplete. He thought there must be a deeper, deterministic theory hidden beneath. This philosophical conviction is what drove him to work tirelessly on the unified field theory, even when the mainstream physics community turned its attention elsewhere. Let's look closer at the bottom section of the page. Einstein begins to define his generalized field equations using mathematical relations involving covariant derivatives, curvature tensors, and connection coefficients. The symbols you see, I, Tio, and the derivatives, are part of the geometry of spacetime. Einstein's idea was that by carefully redefining these terms, he could express both gravitational and electromagnetic interactions as different aspects of one underlying structure. This was a monumental task, unifying two fundamental forces without the tools of quantum field theory or string theory, which would come decades later. Einstein never completed his unified field theory. His equations, although elegant, could not explain the quantum behavior of matter. They also lacked experimental support. But this 1925 paper remains a landmark in the history of science. It inspired later generations of physicists to search for unifying principles, from gauge theories to string theory and modern attempts at quantum gravity. 100 years later, the dream of a unified field theory continues. Today's physicists use powerful mathematical frameworks like string theory, loop quantum gravity, and beyond. But at the heart of all these efforts lies the same question that Einstein asked in 1925. Can all the forces of nature be described by a single, elegant theory? This handwritten manuscript is more than a piece of paper. It is a symbol of scientific ambition, a window into the mind of one of the greatest thinkers in human history. If you found this exploration inspiring, don't forget to like, share, and subscribe to For Science Salah Lotfy channel. Einstein's pen may have paused, but his dream of unity still drives physics forward.
Hello everyone, I'm Professor Dr. Salah Lotfy from the Egyptian Atomic Energy Authority, and you are watching For Science Salah Lotfy channel. Today, I would like to express my deep appreciation and respect to Dr. Yosri Haddad, the distinguished Tunisian physicist, for sharing such an important scientific insight with the public. Dr. Haddad's contribution through his official page shed light on one of the most significant historical papers in the history of physics, a paper written by none other than Albert Einstein 125 years ago. This remarkable paper, titled Unified Field Theory of Gravitation and Electricity, reflects Einstein's bold vision of bringing gravity and electromagnetism together into a single, elegant framework. Through his post, Dr. Haddad reminded us of Einstein's unwavering belief in the unity of nature's laws. He opened a window for many of us to revisit the intellectual legacy of one of the greatest minds in human history. Such efforts are more than sharing information. They are about building bridges between generations of scientists and encouraging young minds across the Arab world to explore, question, and innovate. As a physicist myself, I truly value this kind of scientific engagement. It reflects a shared commitment to advancing knowledge and honoring our global scientific heritage. Dr. Yosri Haddad, on behalf of myself and the For Science Salah Lotfy channel community, I thank you sincerely for this valuable scientific contribution. Your dedication enriches the culture of science and dialogue in our region. And to all our dear followers and science enthusiasts, thank you for being part of this journey. Your interaction gives science a louder voice. I invite you to share your thoughts in the comments below. Tell us, what do you think about Einstein's quest for a unified field theory? Don't forget to like this video, subscribe to the channel, and activate the notification bell to stay connected with every new scientific story. This is Professor Dr. Salah Lotfy, signing off from For Science Salah Lotfy channel. Together we make science speak louder.